The next property you are going to study is frequency differentiation property. Okay, this property we are mainly using if your given question is multiplied by t. Okay, if any of your given question is multiplied by t or t square or t cube or any t raised to n, then that question has to be solved by applying frequency differentiation property. Okay, so let's see what this property is. If the Laplace transform of x of t is equal to x of s, then the Laplace transform of t into x of t, the Laplace transform of t into x of t is equal to minus of differentiation of x of s in s domain, that is minus d by ds of x of s. Okay, likewise the Laplace transform of t square into x of t is equal to d square by ds square into or of x of s. Okay, that is the twice differentiation. Okay, differentiation to the power of 2 into x of s. Similarly, the Laplace transform of t raised to n into x of t is equal to minus 1 raised to n into d of n by ds raised to n of x of s. Okay, so this questions we are mainly applying this property if you're given question, if you see t in your answer, t is a function of time. So if you see t multiplied with your given question, or if you see t anywhere in your equation, immediately you should understand that this is the formula you need to apply. Okay, if you want, you can just study only this formula, because this formula is applied for all values of n. If you look over here, if minus 1 raised to n, so if n is equal to 1, you will get this equation. If n is equal to 1, you will get this equation. Likewise, if n is equal to 2, you will get this equation. Minus 1 raised to 2 is plus 1. Minus 1 into minus 1 is plus 1. So if you put 2 also, then you will get this equation. Okay, so now we'll learn about the proof. Right? So we know that the Laplace transform of x of t is x of s, which is nothing but integral 0 to infinity x of t into e raised to minus st dt. Okay, you can use any Laplace transform, unilateral Laplace transform or a normal Laplace transform. It doesn't make much difference. Okay, applying differentiation with respect to s on both sides, that is, we are going to apply d by ds on the above equation. So what do you get? You get d by ds of x of s is equal to d by ds. What is x of s? X of s is this one. Integral 0 to infinity x of t e raised to minus st dt. Okay, so this is d by ds. That means you are going to differentiate it with respect to s. So here, if you look at this equation, there is no s other than over here. This is the only term that consists of s, right? Rest of the term is integral with respect to dt and x of t into e raised to. So this is the only term that contains s. So I can bring this d by ds into my integration, inside my integration. So it will be integral 0 to infinity x of t into d by ds of e raised to minus st dt. Okay, since here only the s, so this is the only thing I need to differentiate. What is the differentiation of e raised to minus st? It is with respect to s. So here s is the variable, right? S is the variable. So that means the equation will be minus t into e raised to minus st. Minus t into e raised to minus st. That's what you see here. Okay, so here you will get, so that means d by ds of x of s is equal to integral 0 to infinity x of t into, this is the differentiation of e raised to minus st with respect to s. You will get minus t into e raised to minus st dt. Okay, so now I am going to rearrange this just to make it look like my Laplace transform formula. So this is what I get. Right, we know the Laplace transform formula. It is integral 0 to infinity x of t into e raised to minus st. Here you see, instead of x of t, what do I get? I am getting t into x of t. This minus I have taken outside, and this t I have put over here. So this is nothing but this equation. See, this equation is nothing but the Laplace transform of t into x of t. right? This equation is nothing but the Laplace transform of t into x of t. So minus Laplace transform of t into x of t. Okay, so I'm putting the minus sign in the other direction, in the other opposite side of the equation. I get Laplace transform of t x of t is equal to minus of d by ds x of s. Okay, similarly, now if I want to find the Laplace transform of t square x of t, what I do, t square x of t, the same procedure like before. Here this t is multiplied 2 times, so I can divide this t into 2 times, t into x of t. Then I can find the Laplace transform of t into x of t. We know the Laplace transform of t into x of t is what? It is minus of differentiation of x of s, right? So if I am going to multiply by t again, so there's nothing but minus differentiation again, right? So that means minus of differentiation of x of s. Minus into minus is plus, and differentiation is nothing but d square by ds square of x of s. So in other words, how many times you are multiplying by t, that many times you have to apply minus 1 and d by ds, right? That many times you have to apply. Or in other words, Laplace transform of t raised to n x of t. So here n times, so t is multiplied n times, so minus 1 n times, so minus 1 raised to n, and d by ds n times, so it will be d raised to n by ds raised to n into x of s. Okay, so this is how we are applying the statement. This formula we are applying if you see any question in which there is t or t square or t cube or t raised to 4 and so forth. Okay, so let's do some problems on frequency differentiation property. Here, if you look, for these kinds of questions only we will be applying the frequency differentiation property, because in each of these questions you could see t is being multiplied, t square or t cube anywhere. Usually in the exam they will not ask more than t raised to 2, because if 3 raised to 3 means then you have to differentiate it by 3 times. Sometimes the equation might get more complex. Okay, so I'm expecting the questions to be asked up to t raised to 2. All right, so let's do these questions. I want my students, before now I want you all just to pause this video and then do these questions, and then you find the answer and see if you are getting the correct answer or not. Okay, that's the best way. These questions I have took from Anand Kumar textbook. Okay, so you can, now let's do the problem. So here first question is find the Laplace transform of the signal t into u of t. Okay, so we know that the Laplace transform of u of t is equal to 1 by s, right? 1 by s. And also we know that the Laplace transform of t into x of t is nothing but minus d by ds of x of s, right? So here x of t is equal to u of t. Therefore, the Laplace transform of x of t is equal to x of s, which is nothing but 1 by s. So therefore, the Laplace transform of t into u of t is nothing but minus d by ds of 1 by s. Okay, differentiation of 1 by s is minus 1 by s square, which is nothing but minus of minus 1 by s square, which is equal to 1 by s square. Okay, very easy problem, right? Let's do the next question. Find the Laplace transform of t into e raised to minus t u of t. Maybe you can now just pause the video and then try to do this problem and see if you're getting the correct answer. Okay, so the question is t into e raised to minus t into u of t. Okay, so again, so for these kinds of questions, always you should mention which property are you using. It is always nice. I want to mention this to all my students. It is always better that you write the property of whichever you are applying in your problem, because the reason is that even if you get your answer correct, the examiners will be compelled to give you more marks. You see, because you have written your properties, so they know that you know this theorem, you know the property, and your mistake can be considered as a careless mistake. So accordingly, they will just reduce lesser marks. Okay, so always write the property, whichever property you are going to employ in your problems, write those property as it is. Okay, you can write it in your own words. So here also we know that, see, as soon as when I see this t over here, okay, I should understand that I am applying frequency differentiation theorem. Okay, so here we know that the Laplace transform of t into x of t into x of t, the Laplace transform of t into x of t is equal to minus d by ds into x of s. Okay, so here my x of t is nothing but e raised to minus 2t into u of t, right? And also the Laplace transform of my x of t that I have written over here is nothing but 1 by s plus 2. So therefore the Laplace transform of t into e raised to minus 2t into u of t is nothing but minus of d by ds of my x of s is 1 by s plus 2. Okay, so this is nothing but minus 1 into, so what is differentiation of 1 by s plus 2? It is minus 1 by s plus 2 the whole square. Agreed. We have to learn some basic differentiation property to do these kinds of problems. Okay, if you are not familiar with this property, simply memorize this equation, that is d by dx. Okay, d by dx of numerator by denominator. Let numerator be u of x and denominator be v of x. I think all of you know this equation. You have learned this in school days. D by dx of u by v is nothing but v into du minus u into dv by v square. Okay, just apply this equation in case if you are having doubt of how to find the differentiation. Otherwise, if you can do it mentally, you can write like this. Okay, so this is nothing but minus 1 into minus 1 is plus 1, 1 by s plus 2 the whole square. Okay, suppose if they are asking the ROC also, okay, if they are asking the ROC, you should understand that the given question here, it is into u of t, so this is a right sided signal. So right sided signal here, s plus 2 the whole square is equal to 0, so pole is at minus 2, so therefore the real part of s, since the right side signal, real part of s is greater than minus 2. This is your ROC. You can write the ROC also directly. See, very easy. Okay, next question. Find the Laplace transform of t square into e raised to minus 3t into u of t. Okay, so now you can pause this video again and try to do this problem by yourself. Into u of t. Okay, so here we know that the Laplace transform of t square x of t is nothing but minus 1 raised to square into d square by ds square of x of s. Minus 1 the whole square is plus 1 itself. So d square by ds square x of s. Okay. Okay. So now we are going to here x of t is equal to e raised to minus 3t u of t. Right? X of t is equal to e raised to minus 3t u of t. Therefore, Laplace transform of x of t is nothing but x of s, which is nothing but Laplace transform of e raised to minus 3t u of t, which is nothing but 1 by s plus 3. Okay, 1 by s plus 3. So now I need to differentiate this twice. So the Laplace transform of t square e raised to minus 3t u of t is equal to d square by ds square of 1 by s plus 3. Okay, so this is nothing but, if I differentiate it once, I will get d by ds of minus 1 by s plus 3 the whole square. If I differentiate it once, I will get this minus 1 by s plus 3 the whole square. Okay, okay, maybe I can put this minus 1, take it this minus 1 outside, it will become minus of d by ds of 1 by s plus 3 the whole square. Now again, if I differentiate this, I will get, here the power is 2, so therefore, and so the power is minus 2, here the power is minus 2 is the power, so this will become minus of minus 2 by s plus 3 the whole cube. Minus of minus becomes plus, so the final answer is 2 by s plus 3 the whole cube. This is your answer. Okay, here if you want to find the ROC, you have to immediately say here the pole is minus 3, right? S is equal to minus 3 is the pole, so therefore this is also a right sided signal, so the real part of S is greater sign minus 3. This is your ROC. Okay, now let's do the last question. The Laplace transform of t into e raised to minus 2t sine 2t u of t. Okay, t into e raised to, let me see, e raised to minus 2t sine 2t into u of t. This is the question. Okay, finding the Laplace transform of this. Okay, so we know that the Laplace transform of t into x of t is equal to, the Laplace transform of t into x of t is equal to minus of d by ds into x of s. Okay, so here x of t is equal to e raised to minus 2t into sine 2t u of t. Okay, also the Laplace transform of sine 2t is equal to 2 by s square plus 4, right? So applying this is frequency differentiation. If you say an exponential function, then you can apply frequency differentiation property over here, right? So this will become, so therefore we know that the Laplace transform of e raised to minus 80 sine e raised to minus 80 minus 2t, put 2t, so therefore e raised to minus 2t sine 2t into u of t. Okay, it's supposed to be into u of t over here, into u of t is equal to 2 by s plus 2 the whole square plus 4. Okay, maybe you can write the reason, because the Laplace transform of e raised to minus 80 into x of t u of t is nothing but x of s plus a, right? So therefore this is how we get, this becomes a function. Here a is 2, so you will get replacing s with s plus 2, replacing s with s plus a is 2, so you get 2 by s plus 2 the whole square plus 4. Okay, so now you need to differentiate this. So therefore x of s is equal to 2 by s plus 2 the whole square plus 4. Okay, so therefore the Laplace transform of t into e raised to minus 2t sine 2t into u of t is equal to minus of differentiation of 2 by s plus 2 the whole square plus 4. Okay, so this is nothing but, here I can, if I want, I will expand this so it will become more easy to do this, to do the differentiation, right? So this will become 2 by, this is what, s square plus 2 into 2, so s square plus 4s plus 4 becomes plus 8, right? S square plus 4s plus 8. Okay, so the differentiation of this is minus of, so here u is 2 and v is s square plus 4s plus 8. Okay, so the equation is v into du means s square plus 4s plus 8 into differentiation of 2. Differentiation of 2 is 0 because 2 is a constant, so you will get 0 minus, okay, that is, this is v into du minus u into dv. U is 2 into dv. dv is 2s plus 4. Okay, by v square, s square plus 4s plus 8 the whole square. Okay, minus of minus becomes plus, so the answer is 2 into 2s plus 4 by s square plus 4s plus 8 the whole square. This is your answer. Okay, this is how you do the problem. Okay, this is how you do the problem. Sometimes, you know, if so, here from this problem we can understand that you are going to apply two properties over here. That is, one is the frequency differentiation property, right? Because there is a t over here, you can apply frequency differentiation property, and then there is an e over here, so you have to apply frequency shifting property. See, so two properties are there in this question, right? Two properties are there in this question. Okay, there's another way of also solving this question, right? Another easy way of solving this question is just assume that this e raised to minus 2t is outside and t is inside. So in that case you have to differentiate this first and then you have to shift it. In that way also you should do. I want you all to do that in that method and see if you are getting the correct answer. Okay, learn and do this problem by yourself. Okay, what I mean is that change this question in this form: into t into sine 2t into u of t. Okay, I want you all to first find the differentiation of this and then you apply frequency shifting property. Whatever steps you make, you will get the correct answer. Here what I did is I first applied my frequency shifting property, then only I applied my differentiation. Okay, you can also do the reverse also, right? Because this is a multiplication, you can interchange it however you want. So you can make it in this format also. In that case, then you need to find the differentiation of Laplace transform of this term and then you have to apply the frequency shifting theorem to this term. You can do that method also, and whatever method you are trying, you will get the same answer. Okay.